everyone. Today, our topic is about exponential functions. So we start with the first example or specific example of an exponential function. So the function f of x is equal to 2 raised to x is called an exponential function because the variable x is the exponent. So this is a specific example of an exponential function. So in general, an exponential function is a function of the form f of x is equal to b raised to x, where b is a positive constant and x here is the exponent. Okay, so note that b raised to n is equal to b times b times b times b, okay, n factors or n times. So we multiply b itself n times. So if x is equal to 0, okay, remember that x is an exponent. So if x is equal to 0, then b raised to 0 is equal to 1. Because any number raised to 0 is equal to 1. And if x is equal to negative n, then b raised to negative n is equal to 1 over b raised to n. Okay, take note of this. If x is a rational number, that is of the form x is equal to p over q, where p and q are integers and q is positive, then these equations hold, meaning b raised to x, which is an exponential function or the general formula for exponential function, and since is equal to this, so by substitution, we have b raised to p over q, which is equal to this one, q root of b raised to p, which is also equal to this. Okay? Take note of this property. So here are the graphs of exponential functions. So this one, the blue one, is the graph of f of x is equal to 2 raised to x. And this one is 4 raised to x. And this is 10 raised to x. Okay? Now, while watching this video, try to observe the graphs of exponential functions, and you can list down all your observations in a piece of paper. Okay, so 2 raised to x, 4 raised to x, 10 raised to x. And then this one is 1/4 raised to x, 1/2 raised to x. So what are your observations in this family of exponential functions? And notice also that we have a horizontal line, y is equal to 1. Or we have a point, 0 and 1. Okay, so in your observations, maybe that you notice that all of these graphs pass through the same point at 0, 1, because, what's the reason? Because b raised to 0, so real number raised to 0 is always equal to 1. For b is not equal to 0. Okay? Now, what will happen if our b is less than 1 but greater than 0? Now, take note that b is the base of the exponential function and x is the exponent. So then b raised to x approaches 0 as x becomes large. Okay, so look at the graph. If b is less than 1 but greater than 0, so these are the examples of exponential function with b less than 1 but greater than 0. This b here is 1/4, it's less than 1 but greater than 0. Okay? Now notice that the function or the exponential function b raised to x approaches to 0. Okay? For example, this function, for this exponential function 1/4 x, 1/4 raised to x. This approaches to 0, okay, as x becomes large or as x increases. 1/2 raised to x, for example, it approaches to 0 as x approaches to infinity or as x becomes large. Now, if b is greater than 1, what's the graph? What's the form of the graph? If b is greater than 1, let's say this one, 2 raised to x. Okay? What happened? Then b raised to x approaches what? Approaches 0 as x decreases through negative values. So we look at this graph, okay? It decreases or it approaches to 0. It approaches to 0 as x decreases. Or we say that it increases, it increases or it approaches to positive infinity as x approaches to positive infinity. Okay? So in this graph, tell me what is the domain of the exponential functions? By just looking at this graph, what is the domain? The domain, again, is the set of x's that can make the function defined. Okay, in this case, we only have graphs, okay, from here to here. So what is the domain? The domain is the set of all real numbers. How about the range? Okay, what is the range? The range is what? The range is, what's the range? 0 to positive infinity. Okay, 0 to positive infinity. That's the range. So we have a specific example, and this is an application of the lesson that we had about the transformation method and sketching the graph. So sketch the graph of the function y is equal to 3 minus 2x or 2 raised to x, okay, and determine its domain and range. To sketch the graph of the function y is equal to 3 minus 2 raised to x and determine its domain and range. Now, as I've said before, using the transformation method, one of the requirements is to know the graph of the basic function or the parent function. Now, in this case, we have a parent function or the basic function that can be used to sketch the graph of the whole function, which is 2 raised to x. Now, 2 raised to x is familiar. This is an example of an exponential function. And you know already the graph of the exponential function, right? So, first thing is to sketch the graph of 2 raised to x. So, this is 2 raised to x, okay? It passes through the point 0, 1. And since 2 is greater than 1, so it increases without bound as x approaches to positive infinity. Okay? Now next, since there is minus here, so we have minus 2 raised to x. Okay? So this means that there is a reflection. So all we have to do is to reflect this graph of y is equal to 2 raised to x with respect to the x-axis. So we have the reflection, and this is now the graph of y is equal to negative 2 raised to x. Okay? But there is a 3 here. So this means that we have to shift the graph 3 units upward. Okay? Because this is positive. So this means that this graph will be shifted 3 units upward. So if we have this 0, 1 point, we just count 3 units upward. So 1, 2, 3. So the graph now intersects at 0, 2. Okay? And this one, the horizontal line, which is the horizontal asymptote, originally it is the x-axis, right? But since this is shifted 3 units upward, so we count 3 units, 1, 2, 3. That's why the horizontal asymptote, y is equal to 3, okay, is now the asymptote of y is equal to 3 minus 2 raised to x. Okay, so these are the graphs of the exponential function, as well as we use um, the transformation method to sketch this given graph. Okay, so what is the domain and the range of this function? What is the domain? The domain is, okay, look at the x values. The domain is what? The domain is the set of all real numbers. But in this case, what is the range? Okay, the values of y. The values of y is an interval from negative infinity to what? To 3. Okay? Open interval. Negative infinity to 3. And 3 is not included. Or shall we say is a set of y's such that y is what? Less than 3. Okay, so that's it. Thank you so much for watching and hope you learned something from this video. Again, do not forget to share the learning that you've got from this video to your friends, to your classmates, and you can also discuss with your friends um, about the topic that we have. Okay, so once again, thank you very much and God bless.